Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
July the 12th, 2019, 9 o'clock in the evening for those of us here in the eastern portion of North America. That's our live show coming up right now. And, of course, Universal Time will put it at 1 o'clock in the morning, July the 13th, again, 2019. So, welcome, everybody. And, of course, come on over to chat and ask us questions and post astronomy pictures and stuff like that. What do you think, Nick?
Well, good evening, everybody. We've got myself, Marty, Glenn, Starstorm, and Bat Projects in the chat room. As usual, I'm posting the show to Facebook on my page, on the astronomy.fm page, and of course, it's going to take me. It'll take me probably about 30 minutes just to get it up because it's going to be on YouTube with all the links. Thanks to Starstorm, who's in our chat room. Waving back to Starstorm.
All the links, including the missing links.
Absolutely. Well, the missing link is, of course, somebody who actually works for a certain person in New York who looks after all the creatures that history would rather forget, played ably by the former Samantha Carter of Stargate. Sanctuary, of course. Anyway, saying about missing links, I actually stumbled across a story whilst at work today.
Okay,
so it's a comet story. And it's about the disintegration of Comet C 2019 J2 Palomar. So various members of the Comet Watch group on Facebook, which I'm an admin for, and whose name actually crops up on our show every now and again, have reported the apparent disintegration of Comet C 2019 J2 Palomar. It was first detected by Sulia and Starozeski, I hope I pronounced this right, on images taken on UT 2019 July 6th and 7th. Sulia reported it was a comet was 1.8 magnitude, fainter than predicted in the images taken on in July 6.9, they're saying 0, by a 0.3 meter telescope. Now, the interesting thing is, of course, this comet did actually vanish, and a lot of us were talking about it, and we didn't know if the nucleus had disintegrated or not, and now it is official. The nucleus has disintegrated.
But was it disintegrated in an orbit or in a plunge into the sun?
Well, the thing is, from what I can understand, the comet was about 1.78 to 1.73 AUs from the sun, and at about 1.94 to 1.76 AU from the Earth between June 16th and July 9th, respectively. It was discovered on 2019 April the 22nd from the discovery data, and that was in MPEC 2019 J123. Photometry remeasured using the apertures defined are also listed in the article I posted in the article. So, no, it wasn't a solar plunge.
Okay.
So the Zwicky Transit Facility, now there's a name from the past, on July the 9th shows that the comet had lost its central condensation. Although obviously the disintegration only becomes apparent sometime between the ZTF observation on July 2nd and Marcellus Kolkeri observation on July 6th. Photometry suggests that the process likely started much earlier, possibly in early May. The brightness of the comet increases by 0.6 mag from the 27th of April to May the 9th, then decreased an equal amount from May 9 to July 2nd. Yes, I did see your question, Glenn. I'll get to that in a short while. Well, the typical comet would have brightened by about 1 point mag from the 27th of April through July 2nd. Now, assuming that it followed its normal course. Now, Krugel has also further confirmed the disintegration. I'm quoting, reported a diffuse and somewhat elongated coma measuring about 30 degrees in size towards PA 80 degrees. Now, a lot of this is in French, so you're going to bear with me. I'm trying to paraphrase because my French isn't all that brilliant. So obviously a lot of the work was due to observations obtained with the Samuel Ocean telescope, 48-inch, at the Palomar Observatory, which is a part of the Zwicky Transit Facility project. So as I say, it's interesting to actually get to see one of these things happen prior to its solar plunge. So the fact that it's happened, we've actually recorded the whole event.
It was within range of the SOHO telescope, and it didn't go behind the sun and disappeared. No. It actually vanished right in the imagery of SOHO.
It was literally it's pre going around the sun. So really, this was great for science because we could actually observe this directly, and we didn't have to have an image showing on SOHO of it making its turn around the far side of the sun, and then at least it hasn't done an ISON. Let's face it, it didn't do an ISON on us. So of course, the fact that we were able to get photometry, which means we can actually see it happening much earlier than in the visual observations and regular imaging. So let's say it is fairly interesting. It is fairly unique because we were all hoping like crazy that ISON was going to come around the sun and really do a real great number on us, and unfortunately it didn't. But hey, that happens. That's why comets are like cats. They have tails and they do with them as they wish. But the other thing, of course, is with the Zwicky Transit Facility being able to look at these as well, we have so much more information. And I want to actually say thank you to Charles Bells for bringing Sommeliers' initial report to the attention of the author's report on the actual disintegration. So, as I say, this actually was distributed as an instant email notice comets, credential certification, Quach Z, who is a scientist at Caltech.
So to clarify, did this actually disappear within visual range of telescopes, or did they have to disappear in the range of the SOHO telescope?
This was actually followed all the way before. This all happened before it went around the sun. So it was actually being followed in regular telescopes.
Okay. So before it got too close to the sun to actually see it, that's when it vaporized.
Yeah.
Gotcha.
There is actually a permalink in the beginning of the report that's in the chat room. It goes to the Facebook group, Comet Watch, and it actually has some images of the comet. So you can see that this is actually happening in real time prior to when it was supposed to go into opposition and vanish out of our sight for a while.
Yeah,
all
cool.
heady stuff. Now, go on.
Go ahead.
Well, I was going to say, just quickly going to refer to Glenn's question.
Yes.
Follow the plane of the solar system. Theoretically, a comet can come from any direction in the solar system. Majority of comets come from the Kuiper Belt, and some of them actually come as far out as the Oort cloud, which is actually a spherical encompassment of the solar system. So theoretically, they can come in from any direction. This is why it is so difficult to really say when we're going to get the next really bright comet. I want to welcome Kiwi Little to the chat room, because I did see they came in. Great to have you join us for the live show. But as I say, this is a rare event. It's actually we've captured this comet from when it started to perform to when it actually disintegrated. Maybe I think we're going to start getting some more events like this happening. I certainly hope so, because everybody said that Rosetta and I can't remember. I can't pronounce the Russian's name. Sorry.
Churyumov Gerasimenko.
Yeah. That was kind of a quantum leap in the understanding of comets, and now we've actually had a comet disintegrate before it goes around the sun. Is yet another quantum leap for us, because we've had everything from they've even had 1.2 meter telescopes at Palomar looking at this. That
would have been something. That would have been something to have a probe on that comet when it finally just vaporized.
It would have done, yeah. As I say, this is why a lot of us. In fact, it's one of my favourite questions that we always ask on Comet Watch when we get a guest, is if you had unlimited funds and you could dictate a space mission, what would you do with it, and which comet would you check and stay with? And to be honest, the idea of maybe having a fleet of small probes along the Rosetta lines, perhaps out by Mars, certainly, waiting for something to start coming in, and once we had a reliable orbit, then it can start this little ion engine and start building up some velocity and get there, and perhaps do some fascinating science. The missions like Hayabusa 2 is very much even as important, because we're actually going to get our second set of return samples from the asteroid in this case, but being able to have a return sample mission from a comet, and the fact that you could actually track this comet at a safe distance as it comes into the inner solar system, it starts to brighten, and then it goes around the sun and it comes out the other side. Hopefully, there is no guarantee when a comet goes behind the sun it's going to survive. Some of them dive into the sun's atmosphere, and that's it, they're gone. Poof. But I think this is an area of science. Yeah, we've had so many probes go to Mars. We've had an awful lot of probes go to Venus. Maybe it's time we started thinking about a great little fleet of ships that could go out there. They could wait for something to come in. Maybe even one of those interstellar visitors that come through the solar system. Well, we could go back to Pluto, but that may be a while back. A rover on Pluto? Yeah, that sounds like a great idea. But
obviously have to have some sort of battery other than solar. But
well, yeah, that's why you use strontium-90 snap batteries, plutonium backup. They work brilliantly in the outer reach of the solar system. I love this. My daughter is taking part in the show, and she's coming up with science ideas, and she's already got it into her head. You can't depend on solar panels for everything. Don't you just love that, Marty?
Now have her come up with funding.
I wish. Maybe eventually she'll get to become Chancellor of the Exchequer or something, and then maybe the UK Space Agency will actually do something really great like that. The European Space Agency has its own millennial missions, which is brilliant. And of course, everybody's going to Mars. The Russians have been there, America's been there, Europe's been there, India's been there. It's really sad that we're neglecting comets, because these are pristine snapshots of our solar system that are really, really useful to visit. Now, Aqua for you is saying there's a couple of comets coming in at August, September time, Africana and another Assassin. Okay, so let me just quickly go to cometchasingskyhound.com.
Nothing predicted to be really bright, though. Maybe 10 magnitude, something like that, which is really kind of poor for a comet visually. Not too bad photographically, but visually, 10th magnitude is a pretty poor comet. I have not been able to see with a large telescope some 10th magnitude comets.
Okay, so Black Project has put a link into radioisotope thermoelectric generator, which is kind of the thing that the Voyagers used, and they're still using. Those little power packs are still putting out power. They've had to shut some instruments down, but they still work. Saying that, C2018 R3 Lemon. It's a Northern Hemisphere evening comet in large telescopes. At the moment, it's in Lynx at a magnitude of 6.9. JPL has it at something really, really daft, because if I switch to the Sky Live, they have got it at a magnitude of 18. Now,
slight difference in opinion there.
So anyway, let me just put that link in. Let me just back off a bit, because where am I?
Oh, so you went to Skyhound, right?
I went to the Skyhound site first.
All right, let me try my other. Let's see, other. What you call it? Comet site. Aerith, AERITH.net.
Yoshida's site. Yes, that's
Lemon. They've got it listed right now as magnitude 11.
Yeah. So
11.7 actually, so getting dimmer.
JPL says about 15.96 at the moment. Skyhound says 9.6 in Lynx, 5-degree coma. It's fading at about 0.9 of a magnitude and is moving into Cancer by the month's end.
Mm-hmm.
As I say, it's just one of those things. Now, let me just quickly go back to the comets that Aqua for You mentioned. He mentioned Africano and Assassin.
Yep, this one says Africano is about 12.5 magnitude, and Assassin about 12 magnitude.
Yeah. So C2018W2 Africano is in Camina Palladis, magnitude 12.6. 55.
That's the giraffe.
Yeah.
Very northern hemisphere.
Are you having a giraffe with me too?
Mm-hmm.
It's supposed to be brightening by about 1.1 magnitudes by month's end. Assassin is 2018 N2. It's a comet visible in a 10-inch telescope. It's about magnitude 13. It's about 1.5 degree coma. It's bright. Now, this is important. It should brighten slowly. It's moving into Aries by month's end. Please do not fall for all the guff about such and such a comet is going to be naked eye. Yeah, hype. It's going to be naked eye by the end of the month. It is the biggest load of twaddle ever. Comets are very much variable. They change. They do what the heck they want, which is kind of why David Levy coined the phrase "comets are like cats. They have tails and they do with them what they wish." Sometimes they'll even disconnect their tail and grow a new one, which is interesting. Sounds a bit like a newt to me, but
I think so too.
But as I say, the only other one I can see, in fact, I'm looking quickly scanning through this. Most of these comets are all about 13th, 14th magnitude. You're going to need a very good scope. And you're also going to need, to be honest, a CCD or even a DSLR. Yeah, Glenn's, of course, brought up Gahutek's Comet. That was a very famous one. Everybody was expecting that to really, really perform, to be brilliant, and it fizzled. Comet West was another one, but that was a little better.
Comet West was a lot better.
Oh, yeah, it was a lot better.
Comet West was spectacular.
But as I say, you can't really say, hand on your heart, that this Comet X, Y, and Z is definitely going to produce the show of the century. No. We don't really know. The only one I actually follow on a regular basis is 29P SW1. I hate saying this, Schwackman-Wachmann. It's in Pisces currently. It's in a magnitude of 13.9. It is a variable comet, which means it goes into outburst once a month. And of course, there's a big effort going on to actually image and keep a track on how often it does and when it does, because this is one place a lot of people really, really want a space probe to go, because this is a comet that it's one of Jupiter's little family of comets, but boy does it perform. Mm-hmm. And it's a regular, and it's one of those that you can actually set a clock by. And of course, obviously, at some point in its path, the fissures glaze over very thinly, obviously, because as soon as it starts getting the sun again, they rupture and they produce a spectacular display. Mm-hmm. So really looking upon it, for comets brighter than 15th magnitude, you've got R3 Lemon at 9.6, W1 Catalina at 11.9, W2 Africano 12.6, N2 Assassin 13, M1 Panstars 13.8, good old 29P at 13.9. 2018 A6 Gibbs is a whacking 14th magnitude. Remember, the higher the positive number, the dimmer the object is. And then you've got B3 Linear cruising at 14.8. 68P Kemala is in Ophiuchus at 14.8. N6 Panstars in Canis Major 14.9, and that's got a question mark against it. And that's July the 1st. In fact, they're thinking that by the 15th, it's going to be 15.1, and by the 31st, 15.2. 2019 D1 Flelling is an Andromeda. It's at a whacking 15th magnitude, and 260P McNaught is in Cetus at 15.6 magnitude. Mm-hmm. And actually, that one is brightening slightly. That's expected to be at 14.6 by July 31st. Mm-hmm. But those are the only really decent comets we've got at the moment. But then again, having said that, the solar system being what it is, something can perturb it, kick something into the system, and we may get something really bright and fast just come out of nowhere. It's happened. Mm-hmm. So saying we're not going to get any bright comets this century, I think is a kind of a cop-out. But keeping an eye on places like Skyhound, Sachidi Yoshida's website, the BAA Comets Visual Observation page, and the Sky Live, because you never know what's going to come in, and we may get short notice. And of course, we're now getting these interstellar visitors, which I really think that the world's the space powers should get together and start planning something that could actually intercept one. It would be nice to have a Hayabusa or an OSIRIS-REx style mission to one of these things, even if it's only for a week to do science. The amount of science you could do with a probe being there is probably billions of times better than just getting 1 pixel wide images and trying to judge the shape and everything else from that. Obviously, spectroscopy is possible, but that's about it.
Hayabusa 2 just did its second landing on Ryugu asteroid just a few days ago.
Yeah. And that again is kind of a feat that the actual space probe itself has actually done this. So let me just pull up a link for that. Okay. I actually saw that on my news feed whilst I was at work today.
I just got the article. I don't have any pictures of the surface from the second time. There was one that popped up, but I lost it.
Yep, just 1 second. Here we go.
Okay.
There we go. There's the link. I'm sorry it's such a big thing, but I had it saved to Facebook. But it's flying back. It's actually, I think this is probably the final landing. And they actually used a space cannon repeated into the rock to form a crater for it to sit in. It's got samples from underneath the surface, the engineers are saying. And after it's collected bits of rock, it will fly back to Earth in the hope of revealing clues to the origins of the solar system. It might even help reveal where life came from, which is really great. So it already created itself a landing crater back in April by dropping a copper impactor, which acted like a space cannon and blew open a hole in the rock. And of course, we know that I haven't heard much from OSIRIS-REx recently, but that's going on as well. And one of the other things, of course, I picked up on is, of course, the James Webb Space Telescope. That is back in the news.
What's the latest on that one?
Well, funny enough, according to the article in Engineering and Technology, it's actually preparing for liftoff. It's finally going to get a launch date in 2021.
Okay.
And the ironic thing, it is so heavy, there is no American rocket in existence that can lift it.
Mm-hmm. Yeah.
Well, even by 2021,
Still won't happen.
it ain't going to happen on an American rocket. The only rocket that's capable of lifting the James Webb is an Ariane rocket, and that's going to be launched from Kourou. And this mission has been delayed by 14 years, and it's approximately 10 times over budget.
Mm-hmm.
The nice thing is, of course, it will probe deeper and further back into space than ever before. It may hopefully reveal the first light, the start of the universe, the birth of stars, and who knows what. Yeah, that's right, Black Project, Ariane 5. Ariane 6 is in development, which is going to be another quantum leap. And I'm actually hoping that maybe there'll be a willingness at the European Space Agency to man-rate the Ariane 6. There's already been some scuttlebutt on the back channels that it would be possible, with a few modifications, for maybe Ariane 6 to actually carry Orion. And if that is true, that would be a major step forward. It wouldn't just be reliant on SLS. There would be a second launch vehicle available. Obviously, we're going to have to wait and see what exactly is going to happen. Of course, the greatest thing about James Webb, it's not optical. It is near infrared. It's infrared optics. Once commissioned, they should be able to look back some 13.5 billion years ago. However, having said that, if anything goes wrong out there, no one is going to be able to fix it, because we don't have anything that can take a bunch of astronauts out there, even if we wanted to fix it. And there is nothing serviceable on it. Mm-hmm. Whereas the Hubble could actually be serviced again if there was the willingness. Once Orion is commissioned, even if the SpaceX Dragon capsule is commissioned and fully rated for manned missions, we would have a way to get to the Hubble and possibly do either an upgrade or a repair. Mm-hmm. To be honest, having both Hubble and James Webb in operation together, that would be, for science, would be an awesome thing, because Hubble can look into certain areas. I believe it has an ultraviolet instrument on board, and it could ultraviolet an image in optical
and near infrared, so near infrared too.
But the near infrared instruments on Hubble are not as nearly sophisticated as the James Webb.
Oh, definitely not.
But the thing is, if those two telescopes were to work in tandem, we would be looking at a huge information leap forward. They keep saying that we've got petaflops of information we haven't even touched yet. That is going to go through the roof. Mm-hmm. You are going to have to build facilities who have only one mission in life. That is to store all the information that all the various upcoming missions are going to start beaming back to Earth. It's going to take about maybe even 90 years to go through the information that's going to be available. And of course, obviously, it will be freely available to all the universities and all the credentialed scientists around the world. Apparently, the UV camera was removed on Hubble to fit the CoStar lens system. And Black Project has put a link in about the Ariane 6. Now, SLS, of course, is still bugged by delays. There's been all kinds of issues with production on there, and some of them really shouldn't be happening. You shouldn't be dropping fuel tanks on the ground, because then you've got to go back and rebuild it. You can't just fix it and repair the fuel tank, because basically that means it's flawed. It could actually, when you're pressurizing it to fill it, you could actually have a situation where it ruptures. And if you have astronauts on the top of this giant bomb, because that's what a chemical rocket is, it is a bomb. You are flying on a bomb. You really, really do not want the risk of that happening. That is what technically the rupture in the solid fuel boosters on Challenger was what killed and destroyed the Challenger space shuttle.
Solid fuel tank for the main engines.
No,
The boosters leaked. The boosters leaked, burned a hole into the liquid tank supplying the main engines of the shuttle.
Yeah.
That's clarified.
As I say, that is why you cannot afford to have a flawed tank. And of course, obviously, building these tanks takes time. They have to money. And where is the money coming from? Unfortunately, it's the taxpayer, because the contractor is not being held responsible. I'm sorry. If you take on a contract to build something, you are given schedules, you are given penalties, and if you are the organization imposing the contract, you should be penalizing the contractor for not meeting schedules. They sure as heck did it on Apollo. They gave the contractors who were building the LEM, the command modules, and everything else nightmares for most of the project's life, because NASA was there. They were watching everything. The astronauts had their noses into every nook and cranny, and if something was not right, then the astronauts quite rightly started bitching at the contractors about this, that, and the other. So yeah, the provider of the contract, which in this case is NASA and the US government, needs to get on the contractor's case, tell them to get their fingers out and start penalizing them financially. All right, yeah, the company's probably going to complain like heck. Oh, we got. It doesn't matter. You took on a contract to build a viable space launch system within budget, and you're not doing it. If you really screwed up that badly and under budgeted for the program, your fault. Pay for it, but you still have to deliver. I used to work in defense electronics. I know exactly what it's like. If you don't deliver on time, then they start putting penalties on you. And the one thing I have never, ever heard is that the contractor for SLS getting penalized financially for their screw-ups. Mm-hmm. And in fact, Black Projects has put a link into the chat room about the test tank being damaged.
You know what I heard?
What's that?
I heard that you're listening to the Event Horizon here on Astronomy.fm radio. It is now halfway through our program, about 9:30 in the evening for us here in the eastern portion of North America. July the 12th, 2019. Live program tonight, of course. And we will repeat this program every 4 hours for the next 24 hours. So you might catch us on the repeat. Universal time would be 1:30 in the morning, July the 13th, Saturday morning. So still plenty of time to come on over to our chat room and join in the conversation if you'd like to do that. So come on over. Just go to the homepage, astronomy.fm, and you'll get here. All right. What else? We got tons of stuff.
Yeah, we have tons of stuff. There's even a good Hubble story.
All right.
What is life without a good Hubble story?
There's several good Hubble stories up there right lately. So Hubble's doing a lot of checking around on a lot of stuff.
So Hubble has uncovered a black hole that shouldn't exist. So there's a couple of artist impressions with a picture of the image.
It's not the black hole that shouldn't exist. Read it carefully.
Yeah.
So Hubble uncovers black hole disk that shouldn't exist.
Yeah. So basically, what it is, they found an unexpected thin disk of material furiously whirling around a supermassive black hole in the heart of the magnificent spiral galaxy NGC 3147. It's about 130 million light years away. The conundrum is, of course, the disk shouldn't be there. Based on current theories, it is. Now, however, the unexpected presence of a disk so close to a black hole offers a unique opportunity to test Einstein's theories of relativity. General relativity describes gravity as a curvature of space, and special relativity describes the relationship between space and time. Now, what they're saying is the Hubble image shows off the galaxy's sweeping spiral arms full of young blue stars, pinkish nebulas, and dust in silhouette. However, at the brilliant core of NGC 3147 lurks a monster black hole. It weighs about 250 million times the mass of our sun. Now, Hubble observations demonstrate two of Einstein's theories of relativity. The reddish yellow features swirling around the center are the glow of light from the gas trapped by the black hole's powerful gravity. The black hole itself is embedded deep within its own gravitational field, shown by the green grid that illustrates warp space. I'm sure we've all seen these tables in science museums illustrating how an object like a planet and a star creates a gravity well.
Mm-hmm.
Now, the gravitational field is so strong that light is struggling to climb out. This is a principle described in the theory of general relativity. Material is also whipping so fast around it that it brightens as it approaches the Earth on one side of the disk, and it gets fainter as it moves away. You know what this is? It's called relativistic beaming. It was predicted in the special theory of relativity. Now, so this galaxy is in the northern circumpolar constellation of Draco the Dragon. So you can actually go out and look at it through a telescope. I would recommend imaging it because you're not really going to see that much with the human eye. But when you do, just think of this story. Because it's very rare that they've seen both the effects of general relativity and special relativity in visible light with this much clarity.
Part of the issues with this one is, basically you have two types of black holes and galaxies. Not they're all big, but ones that are feeding a lot and ones that are not feeding very much because there's just not that much stuff around them to go into them and light up the disk. So they're basically looking for sort of a normal, quiet black hole, and they looked at this galaxy because they thought it was going to be a normal, and it wasn't.
No.
Usually, when there's not very much material, the stuff kind of like puffs up more like a donut shape going around the black hole. Now, once like a really massive amount of material, it basically goes into a flattened disk around the black hole. Well, this one is a very thin disk around the black hole, and it's flattened out like a really active galaxy black hole instead of like a quiet disk black hole.
So it's really nice because NGC 3147 is mimicking the disk that you would find in extremely active galaxies with engorged monster black holes. But this is very much a malnourished one. There's not enough gravitationally captured material to feed it on a regular basis. So, of course, the whole problem is, why are we seeing this? And where does this take us in regards to gravitation and in particularly to perhaps even quantum mechanics? Because everybody is, Einstein has said everything that's to be on it. Einstein's predictions and theories work on the big scale. Quantum mechanics works on the small scale. And eventually I think somebody will eventually marry both quantum mechanics and relativity, general relativity, special relativity, and quantum mechanics. And that will give us the most probably the most obvious theory of everything. The one thing that eluded Einstein all his life, he even died trying to find a theory of everything. Sorry if I've got you beaten already with a 20-inch monster. Sorry. But anyway, it's nice. It's great. And to be honest, this is cutting-edge science, given the fact that what we're actually seeing is, let me just get the figures back because I want to make sure I give you it correct. This happened 130 million years ago.
Yes.
So someone says time travel is not possible. It is in astronomy.
In fact, there's a list of stars that are different distances going back, so many light years away from us, and then basically, the closest one 4 light years, and then there's another one. They found one 5 light years, 6 light years. So basically, you could find a star that the light came from when you were born. It's kind of a fun one. I haven't found that. I haven't got that list. I've seen that list before, though. So if you look at that at this particular star that matches your age, you say the light that just left that star took your age to get to the Earth, so you could see it. Those lists are out there.
So,
I don't have one offhand, though.
Stars 55 within 50 to 55 light years. Okay.
Mm-hmm.
Here we go. Delta Aquila, 50.1 light years, median plus or minus 0.6. 51 Pegasi, 51 light years. This is going on my age, by the way.
Mm-hmm.
Jalise 3233, 50.2. Now, going to the other end of the scale, because I only put 55 light years in here, and you're talking about, HR 2721, HD 7924, which has 3 known planets. That's a 54.9 light years, plus or minus 0.5. Jalise 895.4, and Jalise 200. Those stars, their light started their journey to us 55 years ago, or thereabouts. So that you can find a star that started its journey, its light started its journey to you on your birthday very, very easily.
Mm-hmm. But every year you have to find a different star.
Does Name a Star still exist? I hope not, because it's a load of bunk. It's basically someone ripping you off saying, oh, we can name a star for X, Y, and Z. No, you can't. The only people that can name stars at the moment is the International Astronomical Union, and they probably think that Name a Star is probably, and I totally agree, it's a total rip-off.
Mm-hmm.
Same with Name a Lunar Crater.
But there have been some actual NASA programs that are similar to that are legit.
Oh, yeah.
Well, then, we're kind of borderline legit, too. It's like sending your name on a space probe. Well, it's a digital name, so you kind of have your name on it, but it's not like you can, sneak into the facility and grab a can of spray paint and put your name across the side of it just before the launch. That'd be a lot more fun.
I think I can know a few people who probably would try and pull that stunt.
Got an alert notice from the AAVSO, American Association of Variable Star Observers. We put this into our chat room. Looking for people to do some observations before they put the big scope on it. And let's see, here we go. This is a variable star. It's a dwarf nova that they're trying to check out. This is one that I think I remember they're going to use. Is it the Chandra they're going to use on this one? Yep. They're going to use the Chandra on it. Something strange about these dwarf novas is that when they're optically dim, they're bright in X-rays. Mm-hmm. And when they flare up in optical, they dim down in X-rays. So they're trying to figure out why. So they're doing some research on, I think, about 20 of them. This is just one that's coming up pretty soon. So they want you to check this one out. It varies between, I think, 14 and 17th magnitude. So we really should be observing this with the CCD. They prefer a V filter. That's optimal.
Yeah.
A V filter it's kind of like the visible range of the spectrum, but the filter actually filters out the X-rays and the UV out of it. So it's not like an actual visual observation, but it'd be a filter that gets rid of the far ends of the visual spectrum.
Now, you're saying about flare stars. Okay, so the nearest flare stars to us, there's Proxima Centauri, 4.2441 light years. One planet, tentative evidence for a second planet. Barnard's star at 5.9577. Largest known proper motion, one known planet. In fact, here's a famous one, actually. If you're a Star Trek fan, Wolf 359. It does exist. It is a real star. It is a flare star. It has 2 known planets. I'll put the list in there so you can have a look at it and have a bit of fun. Okay. Sirius is perhaps the brightest star in the sky. That's at a whopping 1.659 light years. The next flare star is Lutin 726-8. Now, this is 2 stars. Okay, and that's Lutin's 726-8A and 26-8B. What else is there? Oh, yes, Ross 154 in Sagittarius, Ross 248 in Andromeda, Epsilon Eridani. Okay, we've gone to the home of the Vulcans. 3 circumstellar disks, 2 suspected planets, particularly around Epsilon Eridani B. The next star I have for our list is EZ Aquili, and that's going to be Jalise 866 and Lutin 789-6. They're at 11.19109 light years out, A and B flare stars. So again, there's 61 Cygni, another flare star. Struve 2398. Can gas giants have possibly been failed stars? Well, yes and no. They don't quite have enough hydrogen mass to start fusion. So they're not quite brown dwarfs, which splutter along quite merrily, but they're not quite heavy enough to actually fuse hydrogen and start fusion, which would have been very interesting, because that would, if Jupiter had been massive enough and had enough hydrogen, it would have meant Earth becomes Tatooine. So I got a Star Trek reference in, so I had to put a Star Wars in to be fair.
They say at least 10 times. Jupiter had 10 times the mass.
Yeah.
Somewhere around there, it might have started fusion.
So
maybe needed a
times
little
the
bit
mass,
more.
Yeah.
Maybe need a little more, though.
Well, we can always use a Neumann machine, like they did in 2010, to add mass to the planet and start Jupiter to fuse.
Mm-hmm.
Interestingly enough, Jupiter is one of the few places that we know of that may actually have metallic hydrogen as a core.
Mm-hmm.
So, interesting thought. And of course, Juno is still doing great work, taking its slices into the planet's atmosphere and braving the radiation belts. It's one of the Juno's actually done incredibly well. They weren't at least 100% sure of how much radiation hardening the probe needed to come so close to Jupiter to do its atmospheric science. But having said that, it has got an awful lot. It's an awful lot closer than you can actually risk with a manned mission.
Mm-hmm.
Jupiter's environment is a radioactive magnetic hell, particularly for humans, never mind spacecraft.
Not to mention, you can't go down into the planet.
Well, yeah, because the gravity, as Starstorm points out, humans can't go into the planetary atmosphere because we'd get crushed from the sheer gravitation of the gravity of the planet.
Let alone get close to it.
Well, yeah, because the radiation would kill us.
Yep. Yes, indeed.
But as I say, poor old little Juno does it on a regular basis. It doesn't complain, and it's really a testament to the guys, to the boys and girls who actually designed her. Mm-hmm. So, well done, Juno.
Speaking of Juno and Jupiter, by the way, the moon is getting to be is a waxing gibbous, getting close to being full moon pretty soon. Tomorrow night, you'll find the moon right next to Jupiter itself. So check that out. And then 2 days later, which is actually pretty cool, Jupiter is going to be even closer to the planet Saturn. So right now, Jupiter is just west. Sorry, the moon is west of Jupiter. So start out tonight, look for the moon, look a little towards the east, see if you can find Jupiter. Tomorrow night, the moon will be closer to Jupiter, and then the moon will be between Jupiter and Saturn, and then the moon will be right next to Saturn on the 15th. So all real cool objects for two nice planets that you can tell all your friends about. Easy to spot Jupiter, easy to spot Saturn within the next couple of days. There was a thing going around because Saturn's approaching opposition that, oh my gosh, you can actually see Jupiter's rings because it's so close. Saturn's rings because Saturn's rings because it's so close to us. It's like, well, yeah, it's one of those fake rah-rah science things. It's like, okay, so it is opposition. for Saturn, which means it's still far away. It's like 750 million miles away from us. And Saturn's pretty much in the sky almost all of the time. So pretty much any night you can find Saturn, except when it's really close to the sun from our point of view. And it doesn't take that much of a telescope in order to be able to see Saturn. The minimum power I've seen the rings of Saturn were 20 power. I actually had a pair of 20 power binoculars, and I could detect the rings around Saturn at 20 power. So pretty much anything you would call a telescope would be able to see the rings of Saturn. Even though we're coming up on opposition just in a few more days of Saturn, it's okay. It's a good excuse to look at the rings, but it's not that spectacularly close to us at all. So, yeah, show your friends.
Marty, you kind of made a true statement before you changed it. Planet Jupiter does have rings.
Well, yes, it does. But you can't see them with a telescope or anything else.
Oh, no.
Except the space probe.
The only really thing that can actually show you it is a space probe, really.
Yep.
Okay, so let me just chuck this in here. Okay. So hopefully that will work. Yes, it does. Yay, me. Okay.
Okay.
So I nicked this from Wikipedia. It's the rings of Jupiter. They're gossamer rings. So you've got a halo ring on the inside, you've got a main ring, and you've got the gossamer rings. And of course, with all ring systems, on planetary ring systems, you have herding moons. So in this case, you have got Adriesta, Mytis, Thebe, and Amalthea, who actually herd the rings of Jupiter. Where have you heard that before? Saturn. Exactly the same theory.
Mm-hmm.
So without the moons literally herding the rings, they really wouldn't exist as long as they have. But as I say, let me just pull up a graphic of Saturn's rings for you as well. Just 1 second. So yes, Marty, you didn't make a mistake, but you corrected yourself when you're speaking about Saturn.
Mm-hmm.
And Saturn, of course, is so light it will probably float in your bath.
There you go. It's actually less dense. The whole average density of Saturn, in general, is less than that of water. So the story goes that if you had a big enough bathtub and put Saturn in it, it would actually float. And you know what would happen if you pulled Saturn out of that big bathtub? It would leave a ring.
Yeah, a scum ring. Yeah, you're quite right, Glenn. Without our moon, we wouldn't exist. Because of the tides that our moon exerts on the ocean and to a lesser degree on the planet, we have a lunar tide and a solar tide, because of which regulates life on this planet. And because of that, we actually exist. A lot of people don't know that, and a lot of people don't like that either, because it means they have to admit the science maybe have got it right. Okay, so I found a better link.
Well, it's all about survival. You have a better chance of survival if you live in tide instead of out tide.
Exactly, Marty. And of course, it's very interesting. Amura is still making headlines. Oh boy. I really wish they'd stop this, because we know what it is. It is not Rama or Rama 2. It is not an alien spacecraft or a derelict alien spacecraft. It is a chunk of rock that has visited our solar system. It's exiting, and we're looking forward to the next one. And this is really, really why we need to have a spacecraft parked in such a place that it can be sent to intercept, go into orbit, and really do a New Horizons.
Well, I think inside of a rocket storage building ready to launch would be good. It doesn't have to be in orbit, because if we put it in orbit anywhere, it's going to be in the wrong spot. Kind of like looking at, meteors. As soon as you look to the south, the meteor happens to the north, so it's impossible. So what you do, Marty, you have a space probe in a northern position in the sky and in a southern position. So you can cover either part of the sky very easily. It doesn't have to be
thundering great piece of technology. We could quite likely go back to something like Voyager technology. We've proven it works. Go back to the nuclear power packs, which a lot of people don't really like. But you know what? We've proven time after time after time that the strontium-90 snap batteries, the plutonium power packs, which are used on these probes, are safe. It's clear we have everything in place to deal with a launch accident. And that was the only reason Voyager ever actually got the go-ahead, because the tree huggers didn't like the idea that they were using nuclear energy on these probes. They tried to stop it every which way they could legally, and NASA proved that it had a setup for any contingency, including the rocket launching the probes exploding on the launch pad. Now, what more can you want?
Well, if you want the best ready to go rocket, you put a rocket in space with as many stages as possible still attached to it, and put it in orbit, and then you start sending fuel to it.
Glenn, color me 60s.
So that basically you have as much as possible fueled rocket in orbit. But then you could go much faster and farther at a moment's notice, because it would take time to bring up that much fuel into orbit and put it into this rocket. So, but once you're up there, you've got mostly fully fueled rocket, and you don't have to have that get off the Earth, waste all that get off the Earth fuel.
Yeah, but basically, Elon Musk has proven he's actually working on the system to refuel a rocket in orbit.
Mm-hmm.
So it can go to Mars, it can meet a fuel tank that's in Martian orbit, refuel, and come back. Glenn, to be honest, the thing is, I had a lot of issues with the fact that people were scaremongering about these power packs that the Voyager probes had. NASA really went to town to make them as safe as possible, and they planned for every possible contingency, including the rocket exploding just as it left the pad. So you can imagine that the actual containers for these power packs are extremely rugged. And they probably even had empty ones that they deliberately blew up to figure out what the best weight to fuel ratio to everything. Moonbase Alpha, yeah, let's bring it on. Let's have Eagles too. But the thing is, the environmentalists hyped it. They tried to scare the American people into believing that it was not safe to use these power supplies. The further you go out into the solar system, the less energy the sun gives you. That is why New Horizons had such power packs. That's why Voyager 1 and 2, and even I believe the Pioneers, had those power packs. It was the only way to power a space probe once you left the inner solar system well and truly. The further you got out, the weaker sunlight is, the less power you got. It means the less science you can do. But as I say, and as to back up for you, I would not suggest Mount Hood. It is one of the top watched volcanoes on the west coast, and it is overdue for an eruption. Not want to scare people, but that and Mount Shasta and Mount
Scare
Helen.
tactics, huh? Uh-huh.
Uh-huh.
You're just like NASA. Or you're just like the scaremongers.
Yeah.
Well, anyways, all right, everybody. Appreciate you all listening in. It's been a great night tonight. Thanks everybody that's been in our chat room tonight. We appreciate everyone being in our chat room and contributing to the show tonight. We'll be back again next Friday night. Don't forget, we got more programming coming up after the Event Horizon. What do you got to say?
Chief Engineer Rob, the away team of Starstorm, myself, and Marty are ready to beam up. We're ready to come home.
I appreciate everybody listening in. Thanks, everyone, for tuning in tonight. And I don't know, got more programming. So same old, same old.
Energize.
Thanks, everybody. See you
Good
all
night.
again next week. Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.